So hi everyone, welcome to today's webinar. So today we are going to talk about MTG's advanced configuration practice guide training. So this section is going to be very practical, and we will cover all the advanced features you need for real-world MTG deployment. So in today's advanced training, we are not going to talk about some basic settings anymore, and instead, we will focus on two key parts. The first, I will introduce all the advanced features of the MTG systems. And the second, I will guide you through real-world advanced configurations step by step, so you can use them directly in the projects. And let's see the course objectives. By the end of the training, you will be able to first, you will be understand what advanced features the MTG supports. And the second is master advanced configuration, like number manipulation, color pool, ACL, and NAT. The third is you can also learn how to set up IMS service on MTG. And also, we also will learn the config SNIP for device mounting and management. So let's take a look at today's structures. We have three chapters. The first is the MTG advanced features, and the second is the MTG advanced configuration. And the third is an SMP. So we are going to talk about, go through them one by one with clear steps and real examples. So let's start with chapter 1, the MTG advanced features. These chapters explain the powerful functions that make MTG flexible in actual projects. So first, we are going to look at the number manipulation. This feature is mainly used when integrating with carriers, especially in PSTN or E1 scenarios. So for inbound calls, carrier numbers usually include an area code like the 0755. And however, in many cases, the enterprise doesn't need it, right? So we can use inbound number manipulation to remove the area code for easier internal use. And for outbound calls, users may dial numbers without prefix. But the carrier may require a phone number format like the 0755. So in this case, we can config outbound number manipulation to add the required prefix before sending the call out. And later, I will give you a demo about using this area code as an example. So first, let's see the configuration. Let's start with the incoming call configuration. First, you need to go to the number manipulation and choose the PSTN to IP calling. So we can see in these scenarios, we need to change the PSTN to IP calling. We need to change this, right? Because people always use the mobile call, and the call will be changed into the MTG, and we need to remove this prefix in MTG. So after select the source PSTN trunk, it usually be the carrier's trunk. And also we need to set the caller's prefix like the dot. The dot it indicates any. So which it means any number. And also we need to set the caller prefix. So we just set the prefix you want to remove, like this area code. And also we need to set how many digits to strap from the left. Like this number, it have 6 digits, right? So we just fill in the 7. So in this way, the PBX will receive a clean number without the operator prefix, like this number. We can see in this, the mobile call have the number, dial the number with prefix, and we just remove the prefix in the MTG. And we also need to change it to the PBX, but we can see after remove the prefix, the number becomes to like the extension numbers. We all know the extension numbers in the PBX, right? Okay, now let's do the opposite for outgoing calls. It's also the same ways. First, we need to click to the IP to IP TSTN caller. Because in these scenarios, with the caller, the caller will be the extension numbers, right? But the carriers, or we can say the operator, need to the area code like this prefix. So in these scenarios, the direction is IP to PSN and the caller, and we also need to change the caller's number. Okay, and then we just select the SIP trunk, connect to the PBX. Yes, in the scenarios, we need also to create a SIP trunk. And then we need to set the caller prefix as the extension numbers, like these numbers. So it indicates the extension numbers. And also we need to fill in the calling prefix. And we don't have any restrictions on calling prefix, right? And in the PBX or in the enterprise, everyone can dial every number, so we don't need to get restrictions on the calling prefix. So we just fill in the dot and it indicates any. And the last, we also need to add the prefix like this area code, this 0755886. So we need to add the operator's prefix in here, and we just transmit this call to the carrier. So the carrier, only by this way, the carrier will accept this call. So this makes the outbound calls display the correct operator numbers. Okay, so here we are going to have a demo here. So let's see these scenarios. And we have a microsave as extensions registered to the UC 350s. Like in here, we can see that the extension just registers to the PBX like we all do in the enterprise, right? And there is a SIP trunk between the UC and the MTG. We can also find in here our MTGs have the UC SIP trunk, and also in the UC each have the MTG's SIP trunk. And also the E1 status, as here, I just make a loop, using a E1 cable to loop through port 1 to port 2. So it connects directly. And so we don't need to care about this part. And in the next part, we need to create a SIP trunk between the MTG and the IBM. So it's also the SIP phone. And instant register to the UC. Here we just create a SIP trunk between the MTG and the IBM, the soft phone. Here we can also see we create a SIP trunk between the MTG and the software form. So, and the root, I already set it, and the most important, we also need to set the number manipulation. So uh, for the incoming scenarios, we need to set up like this PSTN to IP callings, just like we mentioned before, right? So we need to remove these 7 numbers, these 7 digits here. So I just fill in the calling prefix. It's also like always be the area code, and we don't need to make a restriction on the caller prefix. So we just fill in the dot. And also, for the outcome codes, we need to add the area code like this. We need to area this prefix. So the carrier, the operator will accept our codes. So let's just do a call. So here I just type these numbers. So we can see the extension number is H1200, and after we call, it will add this number, this area code. And we can also see in the CDRs, in the UCs, the extension numbers, and it goes through in the SIP trunk, and in these scenarios, and it transmits between the MTG, the port 1 and port 2, and it goes through to the IBM, the software form. Okay, so, and the outcoming codes is also the same ways, right? Okay, let's move to get back to our PowerPoint. Okay, let's look at the caller ID pool. So this feature is mainly used when integrating with carriers, especially in PSTN scenarios. Carriers usually assign a range of numbers to an enterprise. So in some cases, companies require that all outgoing calls use numbers from a specific range, so that the caller ID can represent the company's identities. All right, so we can see like the carriers just allocate this range of numbers to the enterprise, and these numbers will stem both companies' identities. So in this situation, we can configure the caller ID pool to ensure that outgoing calls are matched with the assigned numbers range. So for examples, we have these extensions in our PBX, like this 81 to 81 205. And for example, and we can add the prefix in the MTG. We just add like the prefix, the area code, and we can send to the operators. The operator will make a phone call with this caller number. And to configure caller pool, we start with the caller wide list at here. So we need to set it in the number filter. And also we can just fill in the dots here to indicate the any numbers. And next we will need to define the number range, right? And we need to fill in the starting caller numbers and the number count. So we also need a range, right? So here, like this range, the start number is 200, and we need to 205. So we just fill in the number count 5. And next, we need to bind them together in a filter profile. Yes, we also need to create a filter profile here. So we just need to apply these two options. The color whitelist ID we just create, right? And also we need also to fill in this option, the color pool for whitelist. And after that, we also need to use them in the routing. So we need to apply it in the root. So we just go into the routing and apply it in the routing. So for the outcoming codes, we just apply it in the here, the filter profile idea. Okay, so I will also show you a demo about. So first we need to create a color whitelist here. And we also usually we just fill in the dot to indicate the any color numbers. And here we need also to create a color pool. We need to create the starting color numbers and the number filling the number count to stand its range. And then we need to create a filter profile. So we need to set these two parameters, this filter profile ID and the color pool for whitelist we just created before. And last, we just apply it in the routing. Like we can apply it in the filter profile ID. Okay, so that's the whole process, and let me just make a call. So first, we need to cancel the manipulation. Sorry, never mind. We just going to go ahead. So this is the same way with the manipulation. So we are not gonna to talk about here. Let's move to the next part, the ACL. So the ACL is so this features restricts which IP address can access the MTG web and the telnet. We can set it in the web page, and also we can set it in the telnet. So first we need to get into the network page. We need to go into the ACL whitelist. So first we need to like setting the whitelist for the IP. And here, just like we need to go into this ACL whitelist. I already set them. At here, we can fill in the IP address, and also we can like adjust the access type, like the web or the telnet. So from now on, my IPs like my IPs, the 171 is already in the whitelist, and and in this way, my IP can log in this page. But normally we just use the telnet to configure these features. So let's get into the telnet. But for these types of MTG, it don't have the access control of telnet, right? So we need to access it by the SSH. And the username are also the root, and the passwords is also to be the web password. And in the SSH, we can get into the telnet. And about the ACL command, we need to get into the config modes. And first, like this command, you can track. We set how many ACL restrictions here. Like this, we said we don't get any restrictions on this network ports. And this is a list of our IPs that's in the whitelist. And there is three commands of this ACL. Like we can dial the ACLs and mostly we just use the add and modify and also the delete. So it means add the new address to ACL and modify date in ACL and delete date in ACL. So like I just show you a demo. Sorry. We just modify the rule of our IP. And the password is super admin. So we need to adjust this address, my IP address. Like we need to select the row ID and the new address. We don't have a new address, so we just and this enable zip trunk, yes. And this trunk is also enable the telnet login. But here we just said we can't we can't access the web login. We said no. And here we just quit. And in this ways, our access will be forbidden. So we want to how do we just recover these situations? And in the same ways, we just to modify the rule. Sorry, it doesn't success. So okay, now we just remove the restrictions of the web access. And now we can access the web page. But even we just like we don't have the telnet login, how we do this in this situation? So in these situations, we can access by the console. And once we log in via the consoles, we can enable the telnet again or directly access the web page for configuration. Okay, let's move to the next part. Okay, we just talk about it, but we also use the telnet for the ACL functions. And the next part is like some advanced modes require telnet access. Like we need to switch the mode. Our MTGs have a lot of modes like the E1 modes or transcoding modes. So you can use tools like Putty. Like Putty, I just use to log into the MTG command lines. We can switch modes via telnet or SSH. So by modifying the parameters in the database. So this mode is our traditional mode, the E1 mode. For example, the default E1 mode only supports IP to PSTN. And if customer needs to IP routing, so the transcoding mode, we need to enable it by changing parameters since it's not available by default. Like we can see in our MTG here, we can see in the root, it don't have IP to IP routing. So we need to enable it in the database. So first we need to telnet the MTG and just enter the recovery commands and and we need also to restart the MTG. And for the transcoding sessions, we also need another command like the parameter 22. So this parameters is about the SIP service interface. Like by default, only G1 works, but enabling it, G0 can also run the SIP service. So let me just show you a demo about it. So first, we need to get into the database. And the username and the password is also the SA. And in here, we can just select our mode currently. And here we can find we are at the default mode. So the traditional E1 modes, we just have the PSTN to IP, IP to PSTN. So we need to change it to the transcode mode. We need to update its parameters. So it's just like the S circle, like the circle command. We need to update it. And we need to fill in the ID, the parameter ID. And also the parameter value. And the transcoding modes are always the 3. We just fill in the 3. And we also need to save our change. And after do that, we also need to reboot the device. And we can also use it in the telnet. So the command is the reset GMPU and the IP address of the MTG. Sorry, we just wait the MTG to reboot. We can pin the IP to check it. Sorry. And now we are the transcode mode. And we can see in the routing, we only have the IP to IP routing. So it's not, it's very different with the traditional E1 mode, right? Okay, let's move to the next part. And the transcoding to E1, we just need to update these parameters to 0, like it before, right? Okay, let's look at the IP strategy, meaning the ringback tone. So since MTGs works as a trans device, so sometimes the code size may not provide a ringback tones. So in this case, MTG can generate it locally. We can configure the ringback tones source based on the code directions. Like for PSTN incoming calls, the ringback can be from the local, the IP side, or we can also choose the adaptive. So it determine the printback size based on the negotiations. And for IP incoming calls, we can it can be from the local. The local is MTG and the PSTN side. So the locals means the MTGs plays a fake ringback terms. So in general, it's better to like let the caller side provide the ringback term. But it doesn't support the ringback terms. Our MTG can generate one fake ringback terms. But however, there's a limitation here, right? So if the caller's party is unavailable, like the powered off or rejected by the carrier, the caller may still hear the fake ringback term by MTG and won't know the real status until the call is disconnected. So this kind of issue is usually carrier side related. And we can set the IP profile. We need to get into the IP profile to set it. Like the ringback tone to IP originated from the IP or MS adaptives. Okay, next let's move to the user equal form. We can so this field is not mandatory, so it's mainly used in the specific scenarios to help the caller side determine how to handle the call. So in simple terms, it indicates the numbers is in a phone number format, right? The user equals phone. So the code systems can understand how to process it. So this feature is usually enabled based on carrier requirements, and especially when connecting to the play platforms like IMS. And some systems require the user equals phones to be present. Otherwise, they may not recognize or process the number correctly. So essentially, this is a compatibility options. So after enabling it, we can enable it in the SIP configuration and the SIP parameters. So after enable it, we can find it in the SIP request messages. It will include the user equals phones field. Next, let's look at the NAT configurations. So in many scenarios, the MTG is deployed in a private network while it needs to register to a public SIP server. So the traffic usually goes through a router or NAT device. In some cases, if NAT information is not handled properly, the network may fail to process the signaling correctly, or the mapping may not work as expected. So therefore, we need to configure NAT settings on the MTG to ensure better compatibility and stable communication in such network environments. So based on this, we provide multiple NAT options. So the first is static NAT. The static NAT, we can assign a public IP. Sorry, the static NAT, we can assign a public IP here in the C parameters to the specific interface. Like we can set it in the G1 and also the G0. So after enable it, the MTG will use this public IP when communicating with the SIP server, so the server can send messages back correctly instead of trying to reach a private IP. So for example, if the MTG sends a private IP, the public server may not recognize it, which can cause call failures. But if we provide a public IP, the communication will work properly. And this feature is mainly used to ensure compatibility with public network platforms. So some platforms replies based on like the source IP, which is fine, but others may use values from the contact or from headers. We all know it's about the SIP message. But if those contain a private IP, it may lead to a call failures. So all in all, the static NAT helps improve the compatibility with different server behaviors. So finally, after config the static NAT, we also need to enable it in the SIP trunk settings for it to take effect. And next, let's look at the dynamic NAT. So in some environments, there is no fixed public IP, right? The public IP may change dynamically. So in this case, we can use dynamic NAT, so which allows the MTG to automatically detect and update the NAT public IP. So this helps ensure better compatibility and stable communication even when the public IP is changing. And also we just need to enable it in the zip trunk parameters. But instead of the static NAT, we need to fill in the public IP. For the dynamic NAT, we just enable this option, and it makes sense. Okay, next let's look at the diverse parameter. So this is mainly used in call forwarding scenarios, right? For example, the A calls B and B forwards the calls to C. On C side, some users prefer to see the original caller, like the A, instead of B, right? So in this case, the diversion parameters allows the system to carry both A and B's numbers in the signaling. So this helps the court party understand the original caller and the forwarding path. And we just enable it in the C parameters, and it's an option. We just enable it, and it just makes sense. And we also have some like the Q and PPA. It's also about the call forwarding options. So let's look at simple examples. So in these scenarios, a call is forwarded internally. So like the 70051 calls B, and B forwards the call to the C, the 2000. So in the same message, we can see like the from field shows its number, the 700 and 51. And B's number is carried into the diversion. It's carried in the diversion header. You can see here. And when this is converted to the PRI, the Q.6931, the signaling, we all know about it, the PRI. So the calling numbers represents the original caller, like the 751. And the caller party number is the 2000, and we can see the redirecting number is this number. It's the diversion numbers in the diversion field. So the B is the one who forwards the call, right? So we just fill it in the diversion number, diversion field. So in this ways, the system can clearly identify both the original caller and the forwarding parties. Okay, great. We will finish all the advanced filters. Now let's move into the chapter 2, the MTG advanced configuration with actual project cases. So in chapter 2, we will focus on the most practical scenarios, the IMS configuration of MTG. So let's talk about the IMS integration. So as mentioned earlier, with our network interface and the transcoding or hybrid modes enabled, like the E1, traditional E1 mode or the transcoding mode, the MTG can connect to different IP platforms on each interface. So typically, one side we connect to the carrier, the IMS platform, and the other side we just connect to internal SIP server or application. So for example, in this setup, so in these setups, the MTGs connect to the IMS, and the other side is connected to the SIP server, and the extensions just register to the SIP server. So this is a common deployment scenarios for integrating carrier networks with enterprise systems, right? Okay, so let's just to see its configuration, how we configure it, how we just connect the IMS and the SIP server. So first, we need to create a SIP trunk between the MTG and the core platform of PBX. So first, we just need to create a SIP trunk about the PBX. So we just need to like the address, the IP address, and the port and the protocol. And when connecting to IMS, we need to create a SIP trunk with IMS. So when connecting to IMS, the main difference is from header. We need to choose like the peer domain, and also we need to use the G0. So we need to set the from header to use the peer domain. This is the most different. And this is also the key requirement. So other configurations are mostly similar to standard SIP trunk settings. So why we need to like set the from header to the peer domain, the IMS domain? That is because IMS usually treats our device as a client. So the certain fields may be required depending on the platform. So for example, parameters like access may be needed in some cases, but they are not always mandatory. And the step 3 is the SIP count. And because create a SIP trunk with IMS, we need also to register to IMS. So we need a SIP trunk, we need a SIP account. So for account configuration, you can set it based on your requirements, like the IMS give you the SIP account. You just fill in the usernames and also the ID and also the passwords. But we can also like in the SIP count, we can batch add this username and the password. So this is also a function of the batch add. And the step 4 is a static route. If two network interfaces are used at the same times, and G0, we need to set it in the default interface. But in here, we just set it in the G1 in the default interface as a G1. But when connecting with the IMS, we need to set this into the G0. The G0 is connected to the IMS private line. So it needs to set a static route. That's because the IMS proxy IP and the G0 IP are not in the same subnet, so you must configure a static route. And this is the details of the configuration. Like first, you need to in here, right? You need to fill in the destination network, like the IMS proxy IP address. And also we need to fill in the subnet mask. And always we just fill in the full mask. And we can see the gateway. The gateway is the default gateway, like this G0. So it means a jump from the gateways to the destination network, the IMS network, the IMS proxy server. And in addition, we need also to set up like the IP to IP routing. And we all know the IP to IP routing is not default shows. So we need to enable it. Like we can set it in the transcoding mode or just like this. We can see it also have the default E1 mode parameters like the PSTN to IP routing, but it also has the IP to IP routing. It's called the mixed mode. So in these scenarios, we just one side connects to the PBX and the other side we just connect to IMS, and we just set the two directions routing like the inbound and the outbound. So the inbound is from the IMS to our PBX, and the outbound is PBX to IMS. So we just need to create the routing calls, routing rules accordingly to along calls between the two sides. And here we just didn't set any restrictions here. We don't set the prefix. But in the real world, we need to apply the calling rules that IMS give us. Okay, we will finish IMS configuration. Now let's go to the last chapter, the chapter 3, the SNMP configuration. So the chapter 3 is about SNMP, which is used for remote monitoring and management. So for the SMP settings, the key parameters are the SMP versions, like it have the version 2 and version 3, and the community. So these community configurations, the most important is version and community configurations. And also we need the chat configurations. The trap configurations is like similar to the event reports in UC systems. So when the MTG status changes, it acts as an SNMP server and sends a SNMP chat message to the SNMP client. So this allows us to quickly monitor and detect device status changes. So this is configuration of an SNMP client. We need to configure the IP address of MTG. And we need also to select the SNMP version and also the config the community. Like the community we just set in here. But we can see it has two community, like the read community and set community. It means two directions of this behavior. Like we can read this community and we can read this OID, or we can just set these parameters. So, and we need also to load the MIB file to import the MIB file of MTG. So after this, we can have after enable this, we can monitor the MTG. We can just like browse the MIB tree here. to get the status. We can click these options, these parameters to get its parameters, and also we can query directly by OID. Also, you can just like use the Linux systems. You can also, if you get the OID of the MTG, you can also to search them informations. Like we can use the SNMP work to query OIDs and SNMP get to get specific values. Let me just show you a demo about it. So first we need to check the SNMP parameters in MTG. We need to enable these SNMPs, and we need to choose the SNMP version. And we just usually we just select the typical the mode and the SNMP listen port. So most important things is the version, SNMP version, and the community configuration. And here we just set the particular community. And here we set chat configuration. The version is also the version 2. And this IP we can change to our PC's IP. Like the 171. And the community are also the importance, like it's also the same ways. And here, sorry, let me just restart it. So I just use this MIB browser to serve as SNMP's client. So here we need to configure the address. And here we need to set up like the port, the listen port, and the particular community, the read community and the write community. And we can set the SNMP version here. And also we need to load MIBs or just import the SNMPs, the MIBs files. And after do that, we can just see into this. We can get into the filters of the MTG parameters. And we can find a lot of parameters here, like the device model. And we can see the device model, the hardware version or DSP version, web version, software version. So these parameters we can see in the MIB tree. And also, we can, just we mentioned before, we can set the parameters of the MTG. We can set it like this, the MTG's parameters like the local C port. Like we can set it to 50, 70. Okay. And we can find the change, and we can also check in the web page. And we can also find the web page is also changed. And besides this ways, we have let me check. We have a whole document of the SNIP's OID, like these OIDs. And we can use this OID in the Linux servers or something, or just we can also use like in the applications. And we can get, set, or work here. Let me just check. Here we need to check the device model. Here we use this OID, and we just paste it here, and we can get the device model, the parameters, and we can. So there's two ways about the SNIP gaps. We can select. We can check in the MIB tree, and also we can to access by the OID. And we can also set its parameters. And for the traps, we for the traps is also like the message we can capture is SNIP message, the trap message in the Wireshark. But here we are bound not to talk about it. Okay, so let me check. Okay, today's that's all for today's MTG's advanced configuration training. We will cover the three parts, like the first, the MTG's advanced functions, and the second part, the IMS configuration. In the advanced functions, we learned a lot like the number manipulation, the caller pool, the ACL, the NAT, and the IMS. So the second part, we learned about the configuration of the IMS, and in the third part, we just learned the SNMPs, right? So all these are the core advanced skills, and if you have any questions, just feel free to contact us. Okay, that's all. Thank you, everyone.